we have an opportunity to use vectors to help us with velocity. An airplane flies due west at 200 kilometers an hour, encountering a wind from the north, and we want to know the resultant ground velocity. Well, the way that we can approach this is to represent 200 kilometers an hour due west by a vector. And when a plane encounters a wind, that wind becomes a component in the addition. So the wind is coming from the north, in other words, towards the south, at 150 kilometers per hour. So we have one vector with a magnitude of 200 and another vector with a magnitude of 150. Well, we want to determine the velocity of the resultant vector, which means we want to know the magnitude and the direction. To determine the magnitude, we see an opportunity for the Pythagorean theorem because we have a right angle, and we see that the magnitude of the resultant is 250. So we know the speed is 250 kilometers per hour. We need the direction though. So we see an opportunity here to use SOHCAHTOA if that's our style, or any other trig method will obviously work here as well. And so we see that tan theta, if we let this be theta, tan theta is going to equal 150 over 200, and theta is 36.9 degrees. So now what we have is a plane that's clearly heading south of west. So we can say that the resultant ground velocity is 250 kilometers per hour, approximately west 36.9 degrees south.